Welcome to the Sustainability Nugget podcast. I am Rarasu Maraibi.
And I'm Tosin Folorunsho.
On this podcast, we learn about sustainability by discussing various related topics while focusing on three pillars: the economy, the society, and the environment.
Hi, everyone.
Hello.
Welcome to another episode of the Waste series on the Sustainability Nuggets podcast. On this series, we have been talking about business opportunities in the waste management industry, and one major area for business opportunities in this industry is waste to energy process. Barasu will lead this discussion today because she is well versed in this topic.
Thank you, Tosin. So, on this episode, guys, we'll be discussing what exactly the waste energy means, the global market size, why it's important in our world today, the different types of waste energy process available, the favorable government policies supporting this process, and existing waste energy companies around the world. We'll also be touching on opportunities available in the waste energy industry. Yeah.
So can you define what waste to energy is about?
Yeah, so waste energy is simply a process of energy recovery, or you can see it as a technique of generating energy in the form of heat or electricity and even gaseous and liquid fuels from the primary treatment of waste. So in our first episode on this waste series, which was building $1 million business from waste management, we mentioned that the global waste management market is currently valued at $1.6 trillion as of 2020. Remember, let that sink in again. So now coming to the waste energy market. The waste energy market was valued at $35 billion as of 2019, and is projected to reach about $52 billion by 2028, growing at an annual growth rate of 5.2% throughout the forecast period of 2020 to 2030.
So do you know why it's growing at such a rate?
Yeah, there are several reasons, and I'm just going to highlight some of these reasons. So one major one is the fact that there's an increase in domestic and industrial waste disposal globally, right? And with this increase, there's also a decrease in landfill capacities, which is also leading to an increase in tipping fees. So it's more expensive for you to dispose your waste in landfills, right? And like if you look at the US, for example, the US has witnessed a decline in its number of landfills over the past few years, and is expected to emerge as one of the largest waste generating country. So that's another reason. Yeah. Okay.
So that means like the US is expected to generate more waste, but we don't have spaces. We don't have enough spaces to actually keep dumping that waste in.
Exactly. And another reason is the fact that there's growing energy demands from the end use sector.
So can you explain what the end use sector is?
So by end use sector, we're talking about like the transportation, industrial, commercial, and residential sectors, because these are the primary consumers of energy, mainly in the form of electricity, right?
Okay.
So with this growing demand, like growing waste disposal, growing energy demand, there's also a rise in the environmental concerns regarding increasing carbon emissions from the usage of conventional fuels, that's fossil fuels. And with this concern, it has led to more countries opting for cleaner and more efficient sources of power generation. So waste energy has emerged as one of the viable solutions for countries to meet their carbon reduction targets and be able to switch to cleaner energy technologies. So another reason is the fact that there's really technological advancement in energy recovery to improve the output efficiency of waste to energy plants. With all of these reasons combined, it has led to the creation of favorable regulatory policies encouraging proper waste disposal combined with energy production. And so, because there are favorable policies from the government and there are major market players like companies that are actually converting this waste into energy, it is actually strengthening the growth of this industry. And
Okay,
that's really the reason for the increased growth. Yeah.
So can you give exact examples of those favorable government policies?
Yeah, so there are several government policies across different regions that are implementing these technologies. But like the major regions implementing technologies are in North America, the Asia Pacific, and Europe. So let's come to North America first. In the United States, there are several federal laws and regulations that govern renewable energy grid interconnection. So some of these laws are the Federal Power Act, and this act gives federal authority over electric utilities. We have the Public Utility Regulatory Policy Act that mandates utilities to buy electricity from qualifying facilities. So it's thereby introducing competitions into wholesale power markets, right? And the Energy Policy Act enables electricity generators to participate in wholesale power markets free from security and exchange commission supervision. The Public Utility Regulatory Policy Act also offers the way for small non-utility generators to enter the market, including renewable energy developers. So apart from this was all in the United States, but in Canada, Canada has also set a target of increasing the share of zero emitting sources to about 90% by 2030. Right. So this is actually pushing for cleaner sources of energy to enter into the market.
Does that mean, so you said that the Public Utility Regulatory Policy Act mandates utilities to buy electricity from qualifying facilities. So do you mean that the waste to energy plants would be a part of the qualifying facilities?
Yes, because these are low carbon emitting sources, right? And they're mandating these utility companies to actually purchase power from low carbon emitting generators. So yeah, definitely. That act actually makes it possible for the waste energy generators to actually sell their energy to the grid in order to be part of the grid mix, the energy grid mix in a region. Yeah.
Okay.
In Europe, when it comes to Europe, in Europe, there are direct subsidies, carbon tax, and landfill taxes to waste energy plants. And this is likely going to help drive the regional market over the forecast period, right? So if I should explain that, like since there's carbon tax, it becomes more expensive to use fossil fuels. Landfill tax, it becomes expensive to just throw your waste into the landfill. So this policy is making it favorable for businesses and even individuals to send their waste to waste energy plants. Yeah. In the Asia Pacific region, there's increased government funding for municipal solid waste management, along with growing awareness regarding the waste to energy plants across various economies such as India, Singapore, Indonesia, and Thailand. And this is bound to drive the regional market growth. In India specifically, the government has undertaken various initiatives for managing urban and industrial waste, as it has faced a large number of public health incidents associated with soil and water pollution. Yeah.
So now we know why this industry is growing, or because of favorable government policies, which is also an effect of the fact that we are running out of space for landfills. And it's interesting how you brought up the case with India, where there's a public health crisis because of mismanaged waste.
Mhm.
But so for this industry, what are the benefits of adopting waste to energy processes? Because there are definitely other ways of waste management, right? But what benefits exist with converting waste to energy?
Yeah, so I'm going to go according to the report from the Environmental Protection Agency. So the United States
Mhm.
Environmental Protection Agency actually reported that there's a 1 ton reduction in greenhouse gas emission for every ton of solid waste processed in waste energy facilities. So what this means basically is the fact that waste to energy plant reduces a significant amount of harmful emissions owing to several factors, even including recovery of metals for recycling, because and in waste energy plant they actually do recover metals.
Okay.
So it's also like when you generate energy from
Yeah.
waste, it offsets the carbon dioxide from fossil fuel power generation. So when you are using the energy or the electricity that's generated from waste, you're not using the electricity from fossil fuel, and that's
Yeah.
offsetting that carbon emission. And so there's
Mhm.
also the avoidance of methane from landfills because you're diverting your waste from landfills. You're not sending them to landfills. So methane is not
Mhm.
being generated there. Instead, it's in the waste energy plant where it's captured and used for energy generation.
Okay.
And so, me, like I said before, we are also still running out of space from landfill. So it's important that you find a way to divert that waste to somewhere it can be useful. And waste energy process is really a reliable waste management solution. Yeah.
That's awesome. I think I really like the part where we are addressing the problem with dumping waste in the landfill. We can't keep creating more space for landfills when we can actually, find better solutions, one of which is the waste to energy process. So can you tell us more about this process or processes? What are they?
Yeah, they're on the basis of technology, which is like the way they're like the global waste energy market is divided into the thermal and the biochemical technology. There's also a sector called the others, but these are the two main, thermal and biochemical. So the thermal technology is actually um the largest segment like in the whole waste to energy market, and it really
Okay.
involves recycling energy from municipal solid waste at high
Mhm.
temperature. So it includes different processes such as combustion, which is also known as incineration, there's gasification and pyrolysis. So these are the three major types of the thermal technology for waste to energy process. And the
Okay.
major difference between the three types of technologies I just called is the amount of oxygen that's supplied and the temperature of the process. So
Okay.
due to like the difference in oxygen and temperature levels, it leads to different end products. So in some, it can just lead to CO2 and water, whilst
Okay.
the other, like based on the temperature, it can produce some intermediate useful products. So in terms of gaseous or liquid combustible
Okay.
products. So the thermal technology, like the thermal segment of this waste energy market, occupied the largest revenue share of 82.4% in 2019. And incineration was the major contributor to this revenue growth. So I can just go like just highlight what incineration is, gasification is, and
Yeah.
pyrolysis. Yeah.
Okay. Yeah.
So incineration is really a method of waste disposal that involves the combustion of waste. So when we're talking about combustion of waste, you're literally just burning the waste.
Burning. Yeah.
There's oxygen involved. So
Mhm.
you can incineration is a waste management method on its own where you burn um waste. But now you can recover energy from that process if you use a proper incinerator where it burns the waste and it eats steam, water that turns into steam and drives a generator to drives a turbine to produce electricity.
So
So
this is different from, like, there's open air burning. It's also, I think it's also called incineration, where you're just like burning, but you're not recovering anything from the process.
Yes, and that's even the open air burning is an hazard to the environment.
Right. Yeah.
Right. So, but incineration, it's better to say incineration with energy recovery, right?
Mm-hmm.
Because that you're not just doing it in an open air situation.
It's in a confined space.
It's in a confined space. Is in an incinerator.
Yeah.
That has energy recovery attached to it. That's the steam component, the turbine component, and like a generator that generates electricity. And in proper incinerator plants, there's also like emissions control. So the emissions that comes from the burning doesn't just go into the atmosphere. It's a closed system. So it goes into the emission control where effluents are absorbed and just clean gas is released afterwards. Yeah. So that's incineration, basically combustion. When we look at gasification, gasification is a technological process that can convert any carbon-based raw materials. But in this sense, we're looking at waste biomass, right? Gasification is also used for coal, but we're concentrating on waste biomass here. So it converts the carbon-based raw materials into fuel gas, and it's usually known as syngas. So syngas is CO2 and hydrogen. Yeah, it's synthesis gas, but it contains CO and hydrogen, which can be used for either electricity generation, or it can be used to produce like liquid fuel. Like it's a building block for energy, like energy products, right? So that's what happens there. So this gasification, it occurs like with limited oxygen and water. So unlike incineration where there's like excess oxygen, this it's like a controlled process where they feed it oxygen and steam to generate the products they want.
Another major difference from incineration is, like, apart from the lesser oxygen used, does it go through higher temperature and pressure than incineration?
Yes, it happens in a unit known as the gasifier, and it occurs at a certain high temperature and high pressure environment.
So what about pyrolysis?
So for pyrolysis, it's also a thermal like treatment, right? But with pyrolysis, there's actually biomass pyrolysis and plastic pyrolysis. So plastic can actually go through pyrolysis, biomass can go through pyrolysis. The main difference between pyrolysis and gasification is that pyrolysis occurs in an inert environment. So oxygen is not allowed into that environment, into the pyrolysis chamber. So it occurs in an inert environment at high temperature and pressure. So at the end of the day, in pyrolysis, you get a liquid product. Like you get like gaseous products that can be condensed into liquid products, while some gases remain in gas form. So but the main product here is the pyrolysis oil, also known as the bio oil. On the channel and the podcast previously, I've made a video that demonstrated conversion of plastic to oil through pyrolysis, and I also interviewed CEO of Naka Industries, which is a company that converts plastic to oil using pyrolysis. So if you're interested, you can always check out those episodes. Yeah.
So the methods we have discussed so far are just for thermal technologies. Am I right?
Yeah.
So what's the other technology in the waste to energy process?
Yeah. So the other technology is the biological technology, and like there are different ways in which waste can be converted into energy through this technology. So there's the landfill gas recovery, which just involves capturing landfill gas from landfills. Right? And landfill gas is a product of the anaerobic decomposition of the organic components in
Okay.
municipal solid waste disposed in landfills. So this in the industry, this is like they categorize this as a sector on its own, different from anaerobic digestion. But honestly, landfill gas is literally just biogas from landfill. So it actually comes from the anaerobic decomposition in landfill. But there's also it's also segmented, like another segment is known as the anaerobic digestion segment, right? Because in the anaerobic digestion segment, they actually use digesters. So they build digesters or wastewater treatment plants, and provide like an anaerobic environment for
Mm-hmm.
waste to convert it to biogas. So anaerobic
Okay.
just means without oxygen,
Oxygen,
right?
right. So
Yeah.
the difference between landfill recovery and the anaerobic digestion. Well, I wouldn't say the difference. I think yeah, the difference would be the location. So like
Yes.
the waste is already in the landfill and then you're just
Yeah.
capturing the gas. So we
Yes.
talked about how methane, how when waste is dumped into landfill over time, it emits methane, right? So landfill gas recovery is just like capturing that methane instead of allowing it to escape into the atmosphere. But
Mm-hmm.
for anaerobic digestion, like they actually build plants that
Yeah.
anaerobic digesters, right?
So they have
Where it
to
is
design,
processed.
yes, they have to
Mm-hmm.
design anaerobic digesters, and design a whole process of how to feed the digester system, how to collect the gas from it, and some anaerobic digestion systems they also convert their waste product or the effluents to
Mm-hmm.
fertilizers,
Okay.
right? So there's a whole system. So um, for the anaerobic digestion. So in the anaerobic digestion sector, they can have specific waste streams. So they can convert food waste to biogas, or they can convert animal droppings to biogas, or
Mm-hmm.
get biosolid from wastewater treatment plants and
Okay.
convert to biogas. So that's why it's into to landfill gas recovery and anaerobic digestion. Yeah.
Right.
So there's also fermentation. Fermentation is also another process that falls under biological technology, and this is a metabolic process that produces chemical changes in organic substrates through the action of enzyme. So
Okay.
to understand it better, from fermentation is where you get ethanol, hydrogen gas, and you can also get more enzymes for it. So just think about how alcohol is actually manufactured, right? So
Yeah.
you have to ferment
Mm-hmm.
carbohydrates to get alcohol. Ethanol is an alcohol, but it's
Yeah.
a chemical based alcohol. So yeah, that's where the fermentation comes in. And so in this waste content, we'll be looking at fermentation of waste biomass. So we're
Mm-hmm.
not just
And we are not converting to alcohol. We are converting to fuels for energy, right?
yeah, it's an alcohol, but feel great alcohol.
No, I
Not
mean like
we're not
alcohol that
yeah,
you drink.
We're not converting to food grade alcohol.
Mm-hmm.
We're converting to fuel grade,
Yeah.
like energy grade alcohol. Yeah. So the last technology is really like a combination of some of technologies, and it's known as mechanical biological treatment. So that's the MBT system. So this
Okay.
system is a type of waste processing facility that combines a sorting facility with a form of biological treatment, such as composting or anaerobic digestion. So when if a company adopts this method, right, they
Mm-hmm.
collect they just collect a mixed stream of waste, and in their
Okay.
facility it goes through sorting where they're picking up metals, picking up recyclables, and
Okay.
just separating the organic components that will probably get like if they can actually bring out organic components, maybe it can go to composting or it can go to anaerobic digestion. While some others, if it still mixed, it goes into incineration. So it's just a facility that combines everything. So you don't need to physically sort everything in their process. It sorts and just puts everything in their right place, basically.
Okay, so you are pre-treating the waste, like you are, should I say, so in that same facility, like you are pre-sorting and then you are pre-sorting the waste first. You collect household waste, you pre-sort it, and then it goes into like what, depending on what kind of organic waste it is.
But because they've
goes
combined it, it's called a system. So they're not doing it separately or like it's
Yeah.
already in the whole system. So you
So
want
would
to
this
think
be
about
like,
it. You want to think about it like maybe waste management truck brings mixed sort of waste and just puts in this MBT system, and there's like a conveyor belt with magnets or
yeah,
like and density separator or something
Mhm.
that separates metals and separates the ones that will float or fall, and like the end stream based on what they have attached to it, right? Can be an anaerobic digester for just organics.
Okay.
Yeah,
Okay.
system, yeah.
Okay.
Or composting. So this, because it's MBT, it has to be like combined with a biological stuff that's either
Treatment.
composting or anaerobic. But the most common ones are just combined with incineration. So when they sort out whatever they can sort out, they just burn the rest.
Yeah,
Right.
okay,
Yeah.
okay, okay. So the non-organic components are burned. Are those the ones that are burned?
No, I'm saying like in the regular situation, the more popular situation, that sorting
Okay.
stuff is there, but they don't
And
sort
then
it
it's
to, yeah, they don't sort it to the level where they just bring out biological parts, right?
okay.
Yeah,
Yeah.
so but in the MBT, they have to bring out the organic parts to put it in a biological treatment. So
Okay.
their sorting has to be detailed.
Mm-hmm.
Whatever system they have has to be detailed enough to bring out the biological part.
So earlier you had mentioned that of the two types of waste to energy technologies that we have, the thermal process is the most popular, right? And you said incineration is like out of, so we have under thermal processes, we have incineration, we have gasification and pyrolysis, and incineration is still the most popular. And so some examples of waste to energy companies that mostly practice incineration include Waste Management, Energia, Covanta Energy Corporation. So are there other examples of companies that do something else apart from the thermal process?
Yeah, like most of there are lots of companies, but most of them actually do the incineration, like they just incinerate and convert to electricity.
Mm-hmm.
Some of them is like a combination of processes. For example, the waste management you talked about also produce renewable natural gas.
Okay.
Like they capture landfill gas and convert it into
To
renewable natural
electricity.
gas.
Okay.
Aneja, beyond the clean energy they are providing, they also like create fertilizers from it and recycled water. So like they have, what I'm trying to say is that they do multiple things most of the time,
Mm-hmm.
but like
Mm-hmm.
incineration is usually like just like the
The major.
really easiest part. Yeah. So it's difficult to find like other companies doing like the other stuff. They are companies, but they're not like really popular. But one I've seen is the Blue Fire Renewables, and that company actually carry out fermentation. So they have a patent on concentrated acid hydrolysis technology,
Okay.
where they convert cellulosic waste materials. Cellulosic waste materials, also known as green waste materials, to
Okay.
ethanol. So that falls under fermentation, like in
Yeah.
the biological part.
Mm-hmm.
Um, I talked about that kind of industries previously.
Yeah.
Those ones carry out paralysis or
Right.
plastic paralysis. I found a company called Planex Ecosystems, or what they do is actually design the paralysis plant. So you can buy the pyrolysis plant from them and then operate operate the system of converting either plastic or biomass to oil. Yeah. So, but there are a lot. We cannot talk about all of them here. We can even talk about own biogas that converts food waste to biogas. So there are a lot of them. Yeah.
So it looks like there's still, this sector is growing definitely, and there's room for opportunity or a chance for people to still come into the sector and make great businesses out of it. Mm-hmm. So what are the current opportunities available, and like are there certain challenges that is impeding the growth of these other sectors, like the biological sectors, for example?
So let's start with the opportunities. Mm-hmm. If you're looking at the opportunities, you want to look at the whole supply chain. Let's say supply chain, like looking at the different sections that is needed in the waste energy process, right? Before you can convert waste to energy, be it thermal or biological, you need to design the technology for it. So that's a market space on its own. Designing the incinerators, the gasifiers, the pyrolysis chambers, the anaerobic digesters, the fermentation tanks. That's a sector on its own. If you're really technical, if you're into engineering designs, that's something you can look at to see if you can help design plans for different regions, right? Yeah, so that's one opportunity. Then another opportunity is in the collection and the sorting of waste. One reason why incineration is really very popular is the fact that it can just accept mixed waste, right? And so they don't need to be pre-treating and sorting. They can just throw everything into the incinerator chamber. And so that's like something impeding the other types of technology, because they need specific waste streams. For example, anaerobic digester, you cannot put mixed waste into it. It would destroy the biological process, right? So in order for anaerobic digestion to grow, you really need sorting of the waste to make sure that only pure streams are entering. So even with the pyrolysis and the gasifiers, they need specific waste streams. So there's really need, there's like a lot of opportunity in that collection and sorting side of things, especially for companies that do not have the MBT, like we talked about, and all of the machineries. They need that intermediate help to sort waste and give them pure waste streams. So that's an opportunity that people can dive into. And I've seen this a lot in plastics, like different people, like different companies that work on plastic waste. Most of them actually just solve the problem of collecting and sorting before they give it to the recycling company. So you can see that in every part of waste, not just plastic. You can become a collection and sorting company for biomass. You can do that for metal and all. And so the last opportunity I'll say is the operation of the technology itself. Yes, we see that it's growing, but the regions that we talked about is really just North America, Asia Pacific, and Europe. We have other parts of the world that really need this technology. So you can look at what is being done in these areas and implement it in your own region. But even in this region that is being implemented, the more is needed, because waste that is being generated, only a very few % is being converted into energy. So why is that? So there's need for expansion of this industry. So we need more people actually carrying out the operations of these technologies.
So I think for regions like Africa, there's where the waste management sector is relatively still growing. Like there's should I say there's little in some countries, there's little or no waste management systems existent. So collection and sorting of waste it's time consuming, definitely, it's labor intensive, but if we can combine the technologies aspect, like you're actually automating the process of sorting the waste, then it'd be easy to set up this like waste to energy plants, because you already have like you have the middle
Man.
yeah, you have the middleman that will be doing the collection and the sorting, and then the technologies are being made available.
Definitely. So in order not to extend this episode, we're going to end here. There are a lot of things to go deep into the different industries, what's actually going on in those industries. So, but
Yeah.
like in future episodes, we'll be diving into the specific waste to energy industries like the anaerobic digestion industry, the paralysis industry, incineration and gasification, to really understand their successes and their shortcomings.
We had mentioned when we started this web series that this series is going to be a long series, but we hope that you are actually gaining and learning something from it. So we hope you stay with us till the end of this series, and maybe you would have started a business, or you would be, I guess, inspired to start a business.
Yeah, definitely. So stay tuned and subscribe to our podcast. Bye.
Bye.
Thanks so much for listening to the Sustainability Nuggets podcast. I am Rarsu Maribi.
And I am Tosin Folarunshaw. If you enjoy this podcast, please leave a rating and review on wherever you listen to your podcast.
You can also show your support by signing up for a small donation to help sustain future episodes. You can find all relevant links in the description. See you in our next episode.